Hello, my name is Igor Wojda, and today we'll be talking about clean architecture. I work at Vonage as Android developer advocate. So we make communication APIs. If your application is to send SMS message, WhatsApp message, make audio call or video call, you can use our API. You get the idea. That's us basically. So before we go deeper into clean architecture, let's chat about architecture on the higher level. So why do we need architecture in the first place, or why do we need a good architecture in the first place? You can take it from many angles, but the good point is you want to avoid classes like that, classes that has a few hundred or a few thousand lines of code, where with long methods where it's hard to say what's going on. So they are impossible to maintain, hard to understand, and practically non-testable. So in context of software development, like there is this ecosystem evolution which has massive impact on the way how we develop and maintain our app. So everything is constantly changing, right? Nothing stays the same, and this has heavy and massive impact on process on software development lifecycle. So customer requirements may change, where they will say we want 99 blue buttons and one red big button. Maybe a new library will arrive, right? Either it will be small change that will not affect us that much, but it may be change where a library API change a bit and you need to update your app. Or maybe even worse, your library will be outdated, and then you need to completely redesign network communication. Then we have those OS, new Android version comes, which will bring new features, but also new constraints. Like imagine a few years ago we had this runtime permissions, and for user it's great. Like when app want to use a microphone, user says yes, right? But for developers, we know how it goes. Like now granting permissions, it's much more complicated than just adding them to manifest. Then new devices come in place, right? And for a few years, we just had bigger screens with higher resolutions, but then watches came out, and you have watch with round screen, or new devices that you can unfold them, or they have two screens, or you can roll out them. So this massively impacts things that we have to think about as developers, right? Then we have support for multi-language, and as well multiple programming languages, like not only Java and Kotlin, but also even Groovy, XML, like maybe some pseudo language for text gratification or for SQL. Like everything's evolved, so we need to somehow take this into consideration. A few years ago, Google introduced a Jetpack, where basically they gave us multiple components to improve application development, but it also had a massive impact on the way how we do things. And on top of that, you have a team, right? You don't work alone. So when you look at one piece of code, then let's say you look at one view model, you should know how view models work. So when you open another from another feature, you just understand what's going under. So the goal here is to have like single responsibility classes or all layers that do one thing and do them well, but they also are properly decoupled, because sometimes we have those components that when we do them or test them proper in isolation, they are fine, but when we connect them, they are a bit of messy, and something is wrong here. So nowadays, Android follows something that I would call MVX architecture. So V is of course for a view, X depends. It can be a controller, which nowadays is not used, a presenter, a view model, or intent. This is not Android intent, it's like intent from MVI architecture. So this, of course, kind of implies multiple approaches to deal with the same problem. And then we have this model. So the problem here is that model is a bit undefined, right? The view, it displays data for user interaction. The controller, presenter, view model somehow controls the view. But model does a lot of things, and usually it may deal with network connections, caching, transforming data, business logic, data retrieval. So a lot of things is going on there. So this means that our MVX is like not really complete solution. It's more like kind of presentation layer pattern, where up to presentation we know what's going on, but the model is this big mystery, usually in our application. So looking at high level, we can improve our MVI. We will go with view model because this is what Google recommends nowadays, and this is how software evolves. So looking at high level, we can improve our model a little bit by splitting it into repository that has some kind of data sources. So one might be like network data source, another will be local database or in-memory cache. So this kind of from view model perspective, view model would say, give me the data, but it may not care really because these come from local cache or network. And those components fits quite well into clean architecture. So what is clean architecture? So clean architecture focuses to think about our applications in a bit different way. So think about those kind of group of use cases, group of features that describes what application is doing, and some kind of plugins that allows us, too much here, yeah, and group of plugins that give our application access to outside world. So it may be like network plugin that gets some data, or maybe database that allows this application to store those data locally. So in core of our clean architecture application is a business logic. So this example of the business logic would be give me or patients, or give me or users that have over 18 years old, something like that, or maybe filter some data in certain way. Then around it, we have things like libraries and frameworks, UI, and of course, our data sources. The idea is that the business logic itself doesn't depend on anything else. So to understand our clean architecture a little bit closer, we need to take a look at something that is called dependency rule. So we have those circles within dependency rule where in the middle we have entities. Then like outer circle are use cases, which are business logic. Then view models that controls the views, and some repositories that controls the data. And UI and data source in the outer. So the idea here is that nothing within inner circle knows about things in outer circle. So our use cases doesn't know about the view models or repositories. Our view model doesn't really know much about the UI. It doesn't depend on UI in this way. So this is basically the dependency rule. It's important to distinguish it from data flow, where basically, let's say, some interactions like from user goes through all the layers down and usually back, right? So if you want to get some data, we click some put on UI, this we call method on view model, run some use case, open repository will get data from data source, and this would be emitted somehow back into UI. So how would we can implement this in Android by splitting this into three layers. Those vertical lines represent boundaries between layers. We may have more layers depending on your application. Just to keep things simple and demonstrate the idea, we'll go with three. Later in the links, you will have projects that may show you more. So what's important here that domain is in the, so we have this data flow, dependency rule, kind of both ways, and the domain that should stay independent from any other layers. So the idea here is to have small Lego pieces, small blocks that allows you to build a house, which is our applications, that are decoupled with single responsibilities. Some of those components you've seen already in MVX approach. Of course, dependency rule applies, and use cases should be independent from presentations and data layer in this example. So if you want to make our use cases independent, right? So how we will do it? Because normally, like use case, which is business logic, let's say, give me the users, would require some network connections to get the data, right, from our, let's say, from our server application. So normally, like use case depends on this repository to retrieve this data. So the way to kind of reverse this dependency is to use dependency inversion, where basically we can change the direction of dependency between classes, and this can be achieved in three simple steps. So first, we would define some kind of interface within our our domain layer in this example. Then our repository class would implement this interface, and then this repository class or object would be injected into use case. So this means that use case in practice depends on the interface, but not on the concrete implementation. So this means that domain layer doesn't really depend on our data and data sources, but rather they depend on the abstractions. So this would be the order of the dependencies going kind of inwards our circle. Oh yeah, and we have those entities in domain layer as well, which basically are, I would say, core data models for our applications. So before going deeper, let's see how typically maintained model can go wrong, right? So let's say we have our model that represents user. So for fields, right, basic data ID, first name, last name, date of birth, nothing complicated. Then over time, we decided to download this data from network. So we would add some JSON annotations just to for the JSON library to know how to parse data into our properties, how to parse network data into our properties. Then over time, we would want to store this locally. So we would add more annotations, but this time for room. So we know how to store those data within our database. And of course, the entity annotations for defining the tables, like primary keys and columns, everything here. Then over time, we may need some kind of derived properties to display our data in better way, one like full name or some kind of extra property derived from user data. So every one of those steps was kind of logical, but we ended up creating this big GAD model. This that tightly couples like a network database, UI, and may create some problems for us. Also keep in mind that those are only 4 properties, and this is already kind of hard to read. But typical production models will be usually much larger. So how this can break our application? Imagine you will change some field on may remove some field from network or from database, and this will result in probably crashing applications, because you need to keep in mind that you cannot update applications everywhere for the users. So some users will have older version that may have one field more than needed or one field less. The database may be inconsistent. So this kind of everything's mixed in one bag. So it's quite easy to break and have a null pointer exception somewhere. So what is the solutions for that? So the solution is to have separate data models for different layers or different data types. So we'd have one data model for our network data, one for our local database, one for our domain, and one for our presentation if it's required. We need some kind of mappers as well to map those data, because again, domain cannot depend on data, but we'll get back to this soon. And maybe the mapper for every model as well. So separate models would look like, we would have this network model that has JSON annotations, which is one class, another class that is our model for database that contains annotations for the room library. Then another model for the domain, which we want to try to keep away from everything. So no library annotations here. Ideally, even no the Android platform dependencies. Although sometimes it's difficult to do in practice. And presentation layer if we need to display data in a specific way. Because keep in mind that we want to keep our views simple and dummy, mainly because views are very difficult to test. So simple if statement, maybe simple loop, but mostly we want to just map some kind of data to the view and avoid any logic there. right? Because we know we have activity life cycles, a lot of things may happen in Android. So app can end up in weird states that are not that easy to repeat, and this may result in UI glitches or some kind of crashes. So this is how our models would look like, and certain kind of data would have exactly the same representations across all of them. So if you want to represent username, this will be string in network, stored as string in database in our view model, in our domain model, and in representation as well. However, certain data may have different representations. So let's say we download our data from network, and this is the date. So from network, we'll get data, which is a string to represent ISO 8601 format, which is basically time that contains time zone, which is helpful for mobile applications. In local database, maybe we just want to store it as Unix timestamp, which is an integer. In our domain layer, we could store it as some kind of datetime object, mainly because it's much easier to perform operations on data, like compare two dates between each other, adding two dates. And in presentation, we would store it, display it as string according to user local settings. The same data, totally different ways of storing and representing. So let's quickly get back to the mappers. So those small classes that are kind of glue between different models. So mapper is at very high level. It's just class or function that takes model of one type and return a model of another. So implementation, there are few ways to do it in Android. Like one would be mapper interface. Like I don't want to really go deep into details. I just want to show you a little bit, just to give you the idea. But basically, again, our function takes one model, and in this case, maps all the properties to another, which with exceptions of date of birth, where we want to change the format a little bit and actually parse a string into datetime object. Right. With Kotlin, we can also do this a little bit differently. Like instead of having interface, we may have extension, which has not much nicer API to use, but it is a little bit more tricky to test. So let's look at individual implementation of the components within architecture. So Vue, as I said, it's simple. So nowadays it would be a fragment especially if you use navigation components, like nothing out of ordinary there, just UI. A view model would be custom view model that extends view model from Jetpack. Let's say we have a method that Vue would call like get users, where we would get the data in a synchronous way from right? So you can use Kotlin coroutines like here, or you can use RxJava, or maybe even live data. Although, as far as I know, live data is more designed to work from view model to the view, rather than through all your application. So this use case would be executed. Use case would give us some kind of results. Usually it's a success or error. Sometimes you may have states like loading, and then you would perform some kind of decision make based on this data and update the view accordingly. Next, we have a use case that represents business logic. So use case again is usually very simple class. So in this case, we just have a method that gets us the list of users from the repository, but also performs some kind of simple operations like filtering to users according to certain criteria. And sometimes people are asking, why would you need use cases at all, right? You have your API, you can get the data in the format you want. And this is usually true, but not always. Sometimes the API team is kind of busy and they may not give you what you exactly need. So you need to make two API calls to merge them into one. And sometimes you don't have control over third-party API. So it's there what's there. So you need to transform this data in certain way. Or maybe sometimes you are calling two different APIs, and then you need to do something else with your data. So advantages of those use cases, making them platform independent, is that technically you could share it across different platforms. So ideally you would take those use cases and use them for mobile, web, maybe even Raspberry Pi, or your desktop application, because they should be platform independent. So next, let's look at entities. So entities, sorry, this is like simple data models that we've seen before. Just pure data, no logic here. Abstractions. This may be this interface. So our repository doesn't depend on the data layer. Let's look at repository implementation. So repository would inject some kind of service to get data source to get you the data. We have our implementation interface here, and repository usually returns data from some data source. Again, this is simplified example. Normally here, if you have more data sources, you would perform check: do we have a data in cache? Yes, we have. Is it up to date? Yes, it is. So return this back to the user instead of calling network, or data is updated, so get it from network, store it in local cache, and move on. And of course, we need to use our mapper to convert it to domain model from data. So, looking at the whole picture here, there are multiple ways to implement this in Android projects. So first approach would be just use like those docking dependency clear architecture layers as a different packages within your project. So this is a nice place to start if you want to play with things, but you lose kind of this separation between layers. So it's easy to misuse things, so use things in domain that doesn't really depend there. Another approach would be create layers per module, so per module, which looks nicer, but this doesn't really scale well because then you end up with massive data, massive domain layers, and if you wanna change one feature, you need to jump between them. It makes things really complicated. And the approach that works the best I think is the approach where you split just your application to feature modules, and each feature module basically has a complete set of those layers. Unfortunately, we lose a little bit of this dependency because, like, again, you can misuse things, so you would need some kind of linters or extra checks that make sure that you don't misuse things between layers. However, this approach allows you to split the work between different sub teams within your teams. You can tell to the team that feature A is developed by this team, and everything that is required for feature A is there. Of course, we'll have some kind of application module which we want to glue things together, some kind of base feature modules where some things will be reused across different features. But as much as we can, we will keep those features independent from each other. So let's look at data flow within clean architecture. So user clicks a button on the view, then view calls some kind of method on the view model. View model would call our use case in a synchronous way. Then our use case would call repository, which would call the data source, check local cache, data is not there, so call network, get data from network, save it to local cache, then map the data, return this to our use case, return this to our view model, and then present this data to the view. So each components they are small with single responsibilities. So the question is, why we are doing all of this? Like, what is the purpose of defining so many classes, so many building blocks, so many layers? And the main reason behind doing is that it makes our application really easy to change and modify, and kind of makes it independent from external ecosystem changes. So if at some point our tab layout will be replaced with bottom view, which is the new way that Google recommends for navigation, we would change it without affecting our domain layer or our data sources at all. If we change our grid view for a cycler view, this is exactly the same change. Like only view part is changing, the rest of the application stays the same. If we change our data layer, right, and start to switch SQL to the room, then again, domain layer and presentation layer stays untouched. And then if our network library like Volley became deprecated, then we can easily swap it for retrofit without breaking half of our application. if we are tracking things, let's say using Firebase Analytics, we may easily add another tracking source like Mixpanel, without affecting rest of the app. So from Vue perspective, like if, Vue doesn't really care or doesn't really know about what's going on under the hood. So this makes our applications extremely flexible. So another advantage of that is that we can easily test our components in isolations, because each of them has single responsibility. So if you want to test repositories, you would just put a mocks of your data sources and just run all the tests there, right? And of course the mapper. If we test our use cases, then we just need a mock of our repository. If you want to test view models, mapper, and maybe an use case, if use mapper is needed, of course, if we use separate presentation model for view. And view, you usually only some kind of mock of view model if you want to test it. So this means that if you make a change, again, like let's say we change Volley to retrofit, right? It means that most of our tests will be fine. They will be running fine. They'll be guarding quality of our application or the features that we developed. So we will only touch small portion of the application. And if you're a single developer, it doesn't really matter that much. But if you work with a team, especially larger ones, then this makes massive difference. And of course, we can test our mappers as well. So what are pros and cons of this approach? So the biggest con is that we write much more code. Like this is the biggest downside of the clean architecture. So and it's not suitable for us for all the projects. So if you're writing quick MVP like my minimum vital product project where you just have very short life cycle, or you're a single developer, then I would probably not go with that. And there are multiple ways to implement this clean architecture. So many projects on the internet tell you what to do, but they rarely discuss design decisions. So why certain things are done in certain way. But on top of that, we have many pros. And first of all, if this long living project, this will really help you with the project maintenance, because you would probably, if you have to redo something, it will be only small piece of project, not most of it. Works well with great teams, especially teams are either distributed or work in parallels, where we can easily split responsibilities between features, like I mentioned, feature modules. Its classes are usually smaller, so they are easier to maintain. The project scales well, and it's easy to test. So there are a few resources that I recommend you to check out. So there are a few articles about the clean architecture, the initial Uncle Bob architecture, who is inventor of this architecture, and a few projects that I recommend you to take a look if you want to see how this is implemented under the hood, as well as a few talks that should give you better idea. So thank you for your attention. So I will share those slides on Twitter, so no worries here. So do we have any questions? Okay, question number 1: how to simplify mapper if our code base becomes bigger? Mapper is a mapper. Usually, it's a simple class or function that takes one model and returns another. So the only example I can see where this becomes complicated is that when you have those nested models. So let's say user has some kind of user model, has another model within it that contains multiple properties. So the mistake that people can do here is they will create one massive mapper versus you should create each mapper for one model. So if models are nested, each models, even the nested one, should have separate mappers. But besides that, it's more important just keep them consistent across your app. Okay, how do we ensure on domain? Okay, okay, sorry guys, because my Zoom is messing up. Okay, see. How do we ensure on domain layer being part platform independent when using libraries like paging or printing free. Yeah, so as I said, so this is ideal scenario to keep it platform independent, but sometimes you cannot just do it. Ideally it should be independent from any library, but in practice it will depend on Kotlin standards library or Java standards library. So if there is dependency, you need to always keep a common sense. Like if you really need it, or maybe other way around. If removing this would be too much hassle, just do it. But again, this is the exception, not a rule. And exceptions like this will always happen in development. You create this perfect app, perfect model, but something will be different there, unfortunately. Okay, next question. Where we need to put logic for where we want to get data from network and local database is business logic. Personally, so there are two approaches to this. Some people would put, sometimes it may be part of business logic indeed, but personally, I prefer to put it in repository. The way I like to think about it is that from business logic perspective, I just like to say, give me the data, and this is it. Like business logic should not really care where the data is coming from, unless this is really like kind of business logic related. Again, depends, but mostly I would put in repository. Okay, which one is better, MVVM or MVI? And of course, Google is pushing for MVVM. I really like the MVVI approach, which is more reactive approach with this single model that represents common state for review. It's a little bit more complicated to explain and implement. I think for now you could go with both, but my personal preference would be to go MVVI. I just like it more. For using dependency injection, say Dagger, where should we keep our modules and components? Should they be kept in a single module or divided according to type requirements? Personally, the way I like to do it, I like to keep separate modules for separate layers. So I have this like feature modules that contains 3 layers, presentation, domain, data, and each of those layers has like some kind of Dagger or dependency injection submodule, and then I have one more at the feature layer. But again, it depends how big is your project. It's because at the beginning you may have only one model for feature layer, for feature module, but then you may keep this in mind that as your project grow, you will convert it a little bit. It's similar like with use cases, like maybe at the beginning, like they will be there, but if your application is super simple and you just started, maybe you want to skip them for now, but then over time, they will be there. You need to understand, not how our application looks like now, but also how it will evolve over time. Okay, next question. Should one use case perform only one action or multiple related actions? So use case ideally should represent single business rule. I'm not sure how would you define an action, but use case can only be composed out of other use cases, or maybe even extend another use case. So usually I would say one action per use case, but one use case can use other use cases. Like whatever makes sense from business logic perspective. Okay, next one. Is it good or rather wrong? Okay, this one. How to deal with use case which takes data from multiple modules? Yeah, so ideally this shouldn't happen. So ideally, I think you wanna rather keep feature modules independent from each other. If you really if you really need this, I would probably glue this somehow together within like your application modules. But usually you should try to keep those features independent from each other. Okay, next question. Is it good or rather wrong approach to split repository into multiple repository classes inside same module if it turns out to be big? Yeah, usually, it's often when class gets too big, we wanna split it. So I would say definitely yes, go for it. For me, the way I would split repositories, you have like maybe you have at the beginning user repository that gets the data, regarding user, but then some sections grow larger, like maybe security and preferences, like just create, user security repository that kind of get this specific subset of data. It's all about, in project, it's all about readability. It's not about creating those hard classes where you just say, oh, this is it and this is how it's done everywhere. Like your project grows, evolves, so you always need to have like readability and maintainability and scalability in mind when you do things. And consistency across different modules as well, because this is probably one of the most important. Okay, another question. Does build times get impacted when using modular structure? So a few years ago, I would say yes, a lot. But since Gradle, I think 5, they did a lot of work to improve Gradle performance, caching. So nowadays it's much better. I remember that annotations were heavy for project build times. But again, this getting better and better. And now Gradle has a build profiler. So if your build is slow, you can profile it and see which things are slowing down your build. Please share the slide deck. I will share it on Twitter. My name, sir, Igor Wojda is my Twitter handle. But after this talk, I have a roundtable where we'll be chatting with experts. So probably I will do it in hours. So I also invite you for this roundtable to join us, ask more questions about clean architecture and open source, and have a discussion. Okay. So next question, do we need to create 3 entity per layer, entity for presentation, domain, and data? So I would say those are three basic entities. So those one probably you need, but sometimes there can be more. So let's say maybe you want to split data layer into network layer, and that would be let's say Android independent, and some kind of local storage layer that would depend on somehow on Android by using, let's say, local SQL or SQL database. Is it better to have use case class that do too many things, especially multiple use cases in one use case class, or to make many use case classes for each responsibility action? I would usually go with multiple smaller classes, like long term. Usually, this scales better. Next question. If we are using any data from shared preferences, should it also come through use case? Yes, it should come from use case from the data source, definitely. Mainly because this allows you, like, your testing will become easier. How can we manage our repository? Is it good for doing it redundant across multiple modules? Yeah, this is a good question. So my preference is going to trying to keep your repositories like separate per each module. So ideally each module would have separate set of repositories. But sometimes you will end up with things where it will make extreme sense to have some kind of repository that is somehow shared. So in this case, you would again put it in some kind of base module. But again, this is exception rather than a rule. Next question. Is it a bad practice to have modules split by layers, data domain, view module, and features inside each different package? You can still do it; it will work. I would argue that this will probably not scale as well. Mainly because of the just it would be a bit harder to split work for different teams, but this would work as well. But for example, if you want to use, let's say, Android dynamic delivery, when you download only part of the app, certain features, you cannot do it with single module. So you need different feature modules, so user can download different part of the applications. Now, next question. Want to use Redux style coding along with clean architecture. I'm confused how to combine it with use case style coding in my Word events, view external from app lifecycle are trigger points. The naming nomenclature, the naming will be always confusing because there are some things that are overlapping, like intents overlap, Android native system intents overlap with MVI intent. But it's more important to kind of understand the concept. What I would encourage you to do to just take a look at kind of Android libraries and projects that follow or that promotes MVI Redux architecture. Just go through a few of them um, and just see what's there. One of those projects is my Android Showcase projects. Like I use Redux a little bit there. I encourage you to take a look at this. This should be a good starting point. Thanks, Igor. Very informative talk. Thanks a lot. I tried to put a lot of time to make this happen. Okay, I think there are no more questions. But if there are, like, join me on this meetup roundtable that will start in 10 minutes. And I hope you really enjoyed the talk. I wish you all the best and have a nice day.